You may feel a little disappointed after these quizzes. I suggest that you don't. The work today was significantly better than the work yesterday. The problem is one tiny, eensy-weensy little phrase that screwed up almost the whole class. If it wasn't for this little phrase, you would have had lots of hundreds because there were tons of 80s in the class. So let's go through this step by step, find any mistakes that you made, and then we correct them and keep going with this. The next 3 days, we're not really going to learn anything particularly new. Maybe a little tiny touch here or there. What we're going to do today, Tuesday, tomorrow, Wednesday, and Thursday is we're basically in prep mode for Friday's test. Boys in the back. Michael, this is extremely important. You know, how many people are involved in the play? How many people are involved in wrestling? How many people are involved in basketball? How many people are involved in something else outside of school that's taking up a lot of time right now? Here's the deal. I just gave a test to my honors kids, and the class basically went in thirds. 1/3 of the kids did fantastic. I mean, incredible. It was a tough test. 1/3 of the kids did a little worse than usual, and 1/3 of the kids got crushed. The reason, and the third of the kids that got crushed, I won't tell you their names, but you would be stunned. You'd say, no way, that kid's really, really smart. The reason's really simple. They're dedicating too much time to outside things, be it wrestling, basketball, the play, band, whatever it is, and not enough time to their schoolwork. So even if you're a super kid whose math comes naturally to, if you aren't dedicating the time to it, you will get beat up on a test. So you have a test this Friday, and it has to be done by Friday because I have to put the progress reports in the computer by Friday. And if you are not on top of your game, you're in trouble as far as that progress report goes and the test. And you know how parents get with progress reports, right?
Yeah.
One thing that every parent thinks is it's a reflection on them. Every parent knows that one of their responsibilities is to make sure that you do your schoolwork. So what some parents will do is they'll see kids doing badly, and that can upset a lot of parents, and justifiably so. They'll make you go to extra help. They'll do all these other things. But the one that really gets to them, homeworks. You miss homeworks, and parents get furious. Because parents know that one of their responsibilities is to make sure that you're doing your homework. And if you are not, they look at it as a slap in their own face. And then, where's the anger going to go to?
Me.
It's going to you. So I strongly suggest that you get your homework done. All right, so the first thing that's really cool is with very, very few exceptions, Michael, with very few exceptions, just about everybody realized that this was going down. Now look, it doesn't mean it's going down tomorrow. It might go up tomorrow. We don't know, and I'm going to get to that in a minute as to why I'm saying that. These are going down by 2s. This guy is going up by 1s. So this becomes 2, this becomes 0, and just about everybody had that right. That's an improvement over yesterday. When it came to writing the function, we were better, not perfect, but we were better. We realized it should be in y equals mx plus b form. We realized, with almost no exceptions, maybe 1 or 2, but not many at all, that the y-intercept is what pairs up with 0. So just about everybody put plus 2 at the end. And we were better at realizing that the slope is down 2, so most people wrote negative 2x plus 2.
I'm gonna put 1.
Yeah, some people messed that up a little bit, but for the most part it looked good. Remember, slope, the same m, is change in the y over the change in the x. Just go on the side and write this. What's the y changing by? Negative 2. What's the x changing by? 1. So that's how you can figure out the negative 2 and put it in there. Okay? But by and large, we did much better on that. Significant improvement in the room. Next, there was significant improvement on the next question too. But you guys got sloppy. Okay. Alexa starts making a design. She's drawing figure A, B, C, D. The next figure is a reflection over the what? X-axis. This is not the x-axis. So many of you went over the y-axis. Every person that went over the y-axis got minus 20. Now, if you had an 80, look on your paper,
60.
that would have bumped it 20 points just by doing the wrong axis. Yes?
I started that, but I was like, I didn't understand it to go that way, but then I realized it just confused me because it had to overlap the other.
You can overlap. There's nothing wrong with that.
That, because when you go over the x-axis, that's what I did. I overlapped it.
That's
and
right.
It was confusing.
But you did get it right, and that's how you wound up getting 100. Look, guys, yesterday I tried to hint to you, and I even said to you guys as we were going over this yesterday, listen, be very careful. And I said, sometimes we flip over the y, and then I said, sometimes we flip over the x, and you got to read the question. Because I knew that today was the x day, and I knew people would say to themselves, oh, I got this, I did this yesterday. One, we'll do that. I got it right. No, you didn't. You know how to do it right. You just picked the wrong line to flip over. You got to flip over the x-axis. So it's count and repeat to the x-axis. And you know what was really funny? Is I could see the improvement in how you wrote it out. People were like, oh, I got this. They're like, oh, I flipped it over the x-axis, or oh, I counted and repeated over the x-axis, and then they ended up over here. And I'm like, oh boy. All right, so 1, 2. This is going to go 3, 3. This is going to go 3. This is going to go 2. And nice word used by Elizabeth before, they can definitely overlap. And you guys were also very good at writing the primes. Oh, this is B prime. Yesterday the primes were left off most papers. So there was a lot of improvement and things were a lot better. What's the number one thing that people did wrong on today's quiz?
Flipped it over the y.
Flipped it over the y-axis. Now tomorrow, it might be the x or might be the y. I don't even remember which one I made it. So I suggest, first off, I think it's a different figure, but read very carefully as to whether it's being flipped over the x or the y. Okay? So I think if you look at the kinds of mistakes that you made, you could say to yourself, you know what, I can figure that out. That's not such a big deal. Okay, so as far as today's do it goes, the drivers in New York State drive 2.8 times 10 to the 8th miles on Monday. On Tuesday, they drive and travel an additional this. How many more miles express the distance in scientific notation? So here's the deal. How many more miles? So let's say that I go jogging. I always like to simplify these problems because these scientific number things, this can drive me insane. It can confuse me. Maybe you feel the same way. Let's make this a little more realistic. Mr. Lindquist likes to ride his bike. That is a true statement. James Clark. And I like to ride normally around 30 miles. 30 miles is a little more than I usually do. Usually I do about 25. So let's say on Monday I do 25 miles. And on Tuesday I do 30 miles. How much more did I do on Tuesday? How'd you get that? You really subtract, right? 30 minus 25? Okay, so what we learned is that we have to subtract the higher number minus the lower number. So, it says here that 9 times 10 to the 8th is the higher number, so 9, that's 3, 4, 5, 6, 7, 8. And then 2.8 times 10 to the 8th is going to be this. And then I have to subtract. 0, 0, 0, 0, 0, 0, 0. Now this becomes 10, and that becomes that. 10 minus that's 2, and that's 6. So I get, now I have to convert this back to scientific notation. This is 0, by the way, here. This is going to be 6.2 times 10 to the 3, 6, 7, 8. So the answer would be that it's 6.2 times 10 to the 8th miles. So we've been over a number of these like this lately. This is like probably our 4th or 5th one in the last couple of weeks. Convert the problem in your mind to regular numbers like you're used to dealing with. Do it that way. Then say to yourself, okay, now that I'm done doing that, the next thing I'm going to do is just do the subtraction. But then at the end, it wants it in scientific notation, so you got to convert back to scientific notation. Does anybody have any questions about that? Okay. Now we're going to get into an extremely important exercise. On your test, there's going to be 8 review questions. Things like what's the slope? What's the y-intercept? Scientific notation. Then there's going to be 13 questions that ask you, here's a point, here's a transformation, tell me the image. Tell me what results out of it. So these questions like here on number 2, these are very much like those other 13 questions on the test. So if you can do these, obviously you're in really good shape as far as doing the question on the test. What's the image of 5, -4 after a dilation by a scale factor of -2? What do you always do when you see a dilation? What operation? Multiply. Good. So what's my final answer going to be? Careful. -10, comma, 8. Good. That's the answer to the first one. Is there anything difficult about that?
No.
No, there's going to be 13 questions like this on your test. Next one, 2, -3. Let's draw that point. 2, -3. There it is. I'm going to reflect it in the x-axis. Which one's the x-axis? Show me with your arms. Good. So when I reflect it over the x-axis, what am I going to get? Is it going to go in the first, second, third, or fourth quadrant? What quadrant's going to end up in? Watch. First, second, third, fourth. Which quadrant is it going to end up in? Jay? No, it's going over the x-axis. Which is the x-axis? This one. Count and repeat. 1, 2, 3, 1, 2, 3. What would be the new coordinate of that point? What would we get? Alan? -2 what? -2, +3 is correct. Okay. Now, we're going to reflect over the y-axis. Which one's the y-axis? Go ahead, count and repeat. What am I going to get? +2, -3. Very good. It's going to end up right over here. Ready? 1, 2, 1, 2. Is there anything about this that seems overly difficult? Because to me, this is very direct. This is exactly what we've been practicing. Now it says a rotation of 90 degrees. So somewhere on one of your papers, I don't care what paper, find a graph real quick and mark the point 2, -3, the original point we have here. Mark that point 2, -3, just with a little dot. Okay? And then do your 90-degree rotation with your paper. What are the new coordinates? What would we get? +3, -2, right? That's a +3, -2. So you're going to have 13 questions like this. It'll say do a translation, do a rotation, do a dilation, do a reflection. You got to be able to get those. We have more of those coming up in just a couple of minutes. Okay, a computer can do a question in an operation in 8.1 times 10 to the -5 seconds. How many can be done by this in an hour? All right, look. If it takes this long to do one operation, that means it can do 8.1 times 10 to the 5th in 1 second. Then, how many seconds are in a minute? 60. How many minutes are in an hour? 60. So if I multiply that, I get 3,600, which is then going to be 3.6 times 10 to the 3rd. And then I have to do 8.1 times 3.6, which is going to be like 25 or 26 point something, times 10 to the 8th, and then whatever, let's just say it was 25.16, whatever, I don't care. Hold it, it would make it 2.516, and this would be 9. Yes?
It's a negative.
But see, that's how long it takes to do one operation.
So -5.
Let me ask you a question. If it takes 1/10 of a second to do an operation, how many can it do in a second?
10.
Right, you make it the positive of it. So if it takes this long to do one, then that means you can do the positive number in a whole second. Okay, that's why it's positive. That's confusing. Okay, now let's go to the next section. Ready? Again, everything we're doing now is review, and we're trying to get a better understanding of what it is we've been working on, Okay, what do you think this is a picture of? Do you think this is a reflection? And please don't yell out the answers, just think about this. We have a whole bunch of them here. We can have reflections, dilations, translations, rotations. Let's look at each picture, and you tell me what it's a picture of. James, head in the game. There are going, on your test, there are going to be 4 pictures just like this. And all you have to do is say, oh, that's a translation. Oh, look at the dilation. Oh, look at the reflection. That's all you have to do. But don't yell in the middle of your test. Okay? I can see it now. Ah, look, number 5, dilation. I got it. No. All right. Are any of these a dilation?
No.
No. How do you know none of them are dilations? Elizabeth?
They don't change the size.
Yeah, they're all same size. Okay. Any of these rotations?
Yeah,
Which one's a rotation?
that one.
The pink one, right?
Yeah.
What about a reflection? Any reflections?
Yeah.
Where? Which one? First one? I don't think so. I think they're sliding everything. I think they're going over and up. Over and up. Get out of here. Over and up, over and up, over and up. Okay, so this is a translation. It's going over, up, over, up. What's this one doing? Over and up. Isn't it sliding? Guys, take a look. Isn't it sliding?
Yeah.
When it slides, we have a translation. What about this one? It's another translation. Slide, over, horizontal, and vertical. What about this one? Over here, what is this a picture of? This is a reflection. This is a flip. Good. What about this one? Blue to red. That's a rotation. Very good. It's spinning up till there. All right. What's this a picture of? Guys, everybody, what's this a picture of? How do you know it's a dilation? Size is changing. What about this one? Dilation. Size is changing. Now, here's the next one. Ready? We're going to take the point -2, -5. Mark that on your paper. -2, -5. Make a mark. Now, there are 8 different transformations we want you to do with this. Talk to the person next to you, go through it, and see if you can find all of those answers. Go ahead. Yeah.
Wouldn't that be right, like -2?
No, that's positive 5. It's down here, -2, -5. No. You want to go with both feet. This one, this one, this one. This is where the x is -2. This is where the y is -5. Point is where the cross. That's perfect. Now, some of these you actually have to use the paper to help you. Some of them you can just look at to figure out, like dilation means to do what operation again? Guys, dilation, what does dilation mean? Multiply. So you just have to do some multiplying on number 1. What's that? You don't get number 1? Dilation just means multiply. So it says a dilation of 4. So you take this coordinate and multiply by 4. What's -2 times 4? It's negative. And what's -5 times 4? So it's -8, -20. This is what there are 13 questions like on your test, guys. You must be good at this. If you are good at this, you will get lots and lots and lots of points. Feel free to talk to each other, guys. Help each other out. If you don't understand, talk to somebody.
When you understand perfectly what you're going to do,
This would be a positive, right?
When you use upside down.
Yes, exactly. Marco, don't forget your paper. Sure, I will. Yep. I'm sorry, what was that? The y's are negative. No, that's y positive. Oh, sorry, y negative, x positive. First off, you're gonna do Y. Yeah, because you were confused. This is where Y is from.
Yeah, I mean this way, so this would be just.
X is positive. It's just a number line. This is the positive side of the number, 0 and that's the negative side. And then this is the positive. So the number line going up. One goes up. Me either. What do we do? Slide of 5 meters to the right. Good. 5. 3. Good. That's right. That's the answer. And that would be 3 negative 2, right? Come on. Yes. Okay, so number 2. You're going to slide 5 meters to the right. Ready? This is the point here. 1, 2, 3, 4. 5 is over here. Up 3. 1, 2, 3. So that point right there. Slide 5 to the right. So you count 5 to the right.
I don't know.
Because everything that says here. No. This is we don't like do this one and then we do the next one based on this one and the next one based on that. Everything goes back to the original color. So we do each of these to the original. That's right. Okay? That's why it's just find the image of negative 2 to 5. Margo.
Right now, 1, 2, 3, 4, 5, 1, 2, 3.
Yes, exactly.
And then I.
What? No. 5, 1, 2, 3. Okay, and then that would be 3 negative 2. Yes. That's when I turn the page. 90 degrees. So what would the new coordinates be? Sorry, 1, 2x. No, that's a y. No. Look, here's my point. Every time it starts with this one. Here's my 90-degree turn. Now, what are the coordinates at this point right now? You got 1, 2, 3, 4, 5. Turn it the wrong way. Hasta la vista. Bye con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Ta-ta. Garusharus.